If the delivery executive has reached before the food is ready, then the executive ends up waiting there. And if the delivery executive reaches after the food is ready, then during this time the food was waiting. Both of these are bad options for us, but in any case the pickup is done once both are ready, and then the last mile happens. Now, just to be clear, last mile is not just reaching the customer's doorstep. It also involves navigating through the society in which the customer is in or the office building, and actually delivering and handing over the food packet to the end customer. So, the first problem is capacity. In very short and simple terms, capacity is about how many orders should I accept, right? So, given I have 100 Ds, let's say, what is the number of orders I should accept? In other words, at what point should I start saying, no, I am not going to take any more orders from the customers? This is the high level problem. Now, given 100 Ds, I can deliver, 300 orders given enough time, right? So, the first constraint is obviously you don't want to serve orders, 2 hours down the line to customers. So, the first constraint is there is a max SLA. I don't want to serve orders beyond this particular time. Now, obviously the second important thing we have already pointed out is how many delivery executives do I have at any given point in time. So, that determines, that's a base level determination. So, if I have 100 Ds, what's the minimum number of orders can I serve? Obviously 100. You have to do better than 100 because you have 100 delivery executives. Now, beyond 100, a lot of factors start affecting, how many orders we can actually serve in the max SLA time. So, there are things like, what is the traffic conditions on the road. If the traffic is less, then each of my delivery executive is actually delivering orders faster, coming back and then taking up the next order and delivering, right. So, now you can deliver probably not 100, but maybe 120, 150, maybe 170 or maybe even more. So, what determines this? One factor is traffic, weather and all are conditions that may happen, may not happen. Customer density, how close are customers to each other, and also customers to restaurant distances, right. So, and distances is actually a proxy for time. You may, in Bangalore for example, 1 kilometer could take you half an hour to travel, right, depending on traffic conditions and all. So all of these factors in conjunction determine what is the true capacity that I have, the same number of Ds. Now, let's say you have 100 Ds still and all of these things remaining the same. Let's say yesterday you delivered, let's say 140 orders. Then with the same number, 100 deliveries, with everything else remaining the same. Imagine that traffic conditions are the same, your odd number of orders that you have got from the customers are the same. Can you still deliver 140 orders, given that you have 100 Ds? May not be necessary, right, because 100 delivery executives at 7 PM in the night is very different situation from 100 delivery executives at 10-15 PM in the night, because many of these hundreds are going to log off in the next maybe 15 minutes, whereas at 7 PM more are going to join the fleet, right. So, your true capacity is not just dependent on these factors, number of Ds and all. It's also dependent on what is going to happen, what is predicted to happen in the next n minutes, right. So, now you see the nature of the problem is such that a lot of external factors are coming into play, right. Things like traffic, weather conditions, there's an accident on the road, there's a road construction going on, multiple things which are not predictable control what is our capacity, right. Another example given here is batching possibility, right. You can also take the same delivery executive and give him more than one orders as long as the customers are nearby and multiple other conditions are satisfied. So, the capacity problem is more about how close to actual capacity can I get. We don't know what the real capacity is. It's very hard to determine that. So, it's more of and what are the costs, right. So, suppose I over predict my capacity, which means I end up taking more orders than what I should have taken. What ends up happening is that customers will now get orders delayed, right. So, they will have a bad experience, and if I under predict my capacity, then I would have left orders and money and hence money on the table, right? So both of these conditions are not true, and hence it's very important to operate at the true capacity level. Now capacity has two notions here. One is the more common form, which is the aggregated capacity. We calculate it at zone level. In some sense, it is a ratio of how many orders we have with respect to how many deliveries executives we have. Now the traditional notion of capacity, and this is the stress in the system. How many orders can we take is an upper bound, right? That bound is traditionally calculated by a lot of learning that happens in a very static and human learning mechanism. That used to be the traditional way of computing capacity, and the way it would still work is because given enough number of days, enough experience of people who are running on ground operations, it used to kind of be okay sometimes, but that's no longer going to scale. It is not responsive to sudden changes in conditions on the road. It's not responsive to weather conditions, because rain happens once a while, and when it happens you don't know what the intensity is and so on, right? So what is the right number where you would stop accepting more orders? So this is one of the challenges, and often what it also leads to is that if I have an incentive as an operations person to serve maximum number of orders, I may tweak these numbers without any scientific reasoning, and that could also lead to bad orders and customer dissatisfaction and so on. So we worked through this problem for quite some time, tried various algorithms, came up with different statistical modelings. As I said, I am from the delivery engineering team, so I work very closely with the data engineering, data science teams and all. Ultimately, the current version that we are working with is called order limiter. It is very much dependent on what is happening in real time on the ground, right? What state the delivery executives are in, where are they in real time, how close are they to their destination, what is happening to the food that is being prepared on the restaurant, was the last signal that we got in time as predicted, or was it delayed by 10 minutes or delayed, or was it early by X minutes. So all of these conditions are taken into account. Things like when will the delivery executive get free is included in the computations, and we now have a much more dynamic version of capacity. So remember, this is not stress. Stress is still the old notion of saying, hey, how many orders I have with respect to how many delivery executives are there. This is more of what is my upper bound. So this kind of a system, as you can see, is very, very dependent on what was my ETA, what was my SLA, what was my ETA, what is the current state of each and every order, each and every delivery executive in real time on the ground. So a huge amount of data processing work is required here. What it helps us do is it helps us reduce those bad orders that we would have taken, and it also helps us avoid any orders left on the table. Now this is a visual representation of how this system works. On the left side you would see for every n minutes of interval we would have computed how many orders we can take in that n minute of interval, and the green graph basically shows how many we actually ended up taking. So as you can see, around lunch time we are operating very close to what we could have taken, and as the lunch time fades away around 2 o'clock or so, you see the gap between the blue and the green graph increases. That indicates that our capacity is unutilized at that time, because the orders have got delivered, but the delivery executives are still available. They are saying, yeah, we are still in the system. Equivalent graph on the right side, if you notice, the points here and here, these are places where we have hit the capacity, and so at that point we would have said, hey, take no more orders. And the yellow line and the blue line here are dynamically changing, right? So that is saying not just what the current capacity is, it's saying, hey, at this point I can take so many orders because let's say all my delivery executives are busy, or at this point I can take so many because now they are getting freed up in the next 10 minutes. The other notion of capacity is point capacity, right? Can I accept this order? And this is also very important because, for example, if you have only 5, let's say, delivery executives at a particular point in day, in a particular point in time, right? These delivery executives could be in the east side of the society because most of the times, breakfast, early morning breakfast orders come from a certain restaurants, and on another side of the city probably there are none, right? So while these 5 are there, I cannot take 5 orders from the west side of the city because it will take too much time for these delivery executives to travel, right? So this is an extreme example, but it happens all the time, where we say कि for this particular order, let us compute, are there any delivery executives available in the vicinity either now or are expected to get freed in the next n minutes. So both of these notion of capacity, as you can see, are fast computations, they are approximate. You can't afford to get all the data in the world, so you kind of do all these computations based on some last known state. And ultimately aimed at preventing both the sides of the spectrum, bad orders on one side and the leaving money on the table on the other side. The other notion is efficiency. In simplistic terms, efficiency is how many orders per delivery executive per hour do I do, right? So there are two notions of efficiency. One is called the assigned efficiency and the other is called simply efficiency. The regular notion of efficiency also includes what is the utilization of my fleet, right? So if you leave that out, in most of the conversation we'll only focus on assigned efficiency part today. Now what are my efficiency levers? How do I control that? So first is obviously who do I assign this order to, right? So I want to assign, a greedy approach could simply say, hey, I want to assign this to the nearest delivery executive possible. But the problem is that for this order, the nearest delivery executive could have been the best executive for another order, right, which is probably closer than this delivery executive is closer to this order, right? So now we are talking about not doing a greedy approach, but doing a more of a global optimization. So there are versions of Hungarian algorithms that we have coded up. I'm not going to get into that because the focus here is not the assignment algorithm, but the focus is what is the basis that we use to do these kind of optimization, right? All of these, the basis is, okay, I know where the delivery executive is. I can estimate the time that this person will take to travel. I also have nuances to say that, there are possibilities that this guy may even reject the order. He may say that, hey, I don't want to do this order. We allow, to certain extent, we do allow this behavior because delivery executives may have certain preference. They may not want to go in certain area, or they may not want to, maybe it's very late, they were just planning to log off from the system when an order came. So rather than accepting that order, they would reject the order. There can be various such situations. So now we are talking about building in those possibilities into our prediction algorithms, building in those possibilities into our predictions of how much time would it take to travel to the restaurant and so on. The other lever is when to assign, right? So for example, if I have to serve an order and I see a delivery executive that is 1 kilometer away, I have a choice of assigning this order to that executive right now, or I have a choice to basically wait for some time and see, hey, is there going to be another delivery executive who may become available, which is closer than 1 kilometer to this order, right? So time dimension is another lever I have. Then, can I batch orders? We talked briefly about batching. What enables batching is that, the customers, 2 customers or 3 customers who I'm going to deliver the order to have to be close enough. Not just in, and the orders have to be close enough in terms of both the source, which is the restaurants, and the destinations, which is the customers, and also in the time dimension. You don't want to, batch 2 orders if they have come 20 minutes apart. You want to batch 2 orders if they were close in time dimension as well. Now, obviously, the reason why this is important is, can I predict whether a specific order is capable of getting batched with another order given all these constants, right? So again, you're talking about, looking at a lot of data, learning from the past and taking real-time inputs. So for example, if there was an order in the system already, 5 minutes back that came in, which satisfies all these 3 criteria, for the order that is coming now, I need to be able to make that decision. Yes, there is an order which potentially, with a lot of certainty can be batched, right? So now when it is important not just to predict this batching because you want to know what the capacity and efficiency of the system is going to be like, but also because you want to promise an SLA to the customer. Right now, imagine that there is no such order which is already there, which is waiting to be paired. Then you basically ask the question, okay, hey, what is the chance that in the next 10 minutes, in the next 15 minutes, you will get another order which will satisfy these 3 conditions, right? So in both, so these 2 conditions are called second order batching and the first order batching, and in both the cases, we again do a lot of data analysis, both real time as well as building data science models to learn these behaviors. The other levers, we talked about those different legs of the journey, order to assign time, first mile time, last mile time, preparation time, customer to customer distance, batching probability. Each of these are data science models, for predictions, and each of these have, specific, error into them. I'll talk a little bit about errors as we go along. The important thing is that all of these models work in unison for us to be able to promise an SLA to the customer. And as you know, errors in these models add up. The second important thing also is that some of these models are used for internal efficiency and internal predictions, right? And some of these models are used to make a promise to the customer. So we also end up doing like different models sometimes to optimize our systems and to make a promise to the customers. The other way we look at data in Swiggy also, especially in the delivery team, is also with respect to trade-offs. For example, if I want to make my efficiency very high, I would want to batch orders together. Now, when I batch 2 orders, I give it to a single guy. There might be another delivery executive who is waiting for an order but gets none, right? So this is a trade-off between what is the experience that I give to my most important resource, which is in this case the delivery executive. You may end up giving them suboptimal experience and they may end up leaving our platform, right? So if I make my operations very efficient, I may compromise on the experience that I give. I mean, they are here to earn money and we are impacting their earning capacity. Similarly, it could also be that if I batch 2 orders together, one of the orders that came in earlier could possibly have been delivered first, right? So that order is made to wait because there is a second order that we are possibly going to batch it with. So there is a trade-off there. The first customer probably is getting the order in the promised time, but lesser or it takes more time than what it could have possibly taken. So there is a trade-off right there. Similarly, when I want to make an assignment, so I want to find the most optimal combination of orders with the delivery executive. Now, while I find the most optimal combination, I may end up starving some orders, right? So some of the orders may never fit into the, let's say I have only 50 delivery executives and every time especially in peak times this happens, every time I have like enough number of orders and less number of Ds compared to the number of orders. And if I keep super optimizing myself, those orders that are, let us say, away from where the delivery executive density is, may end up getting starved. So I can't let that happen because for those few customers whose orders are starving, the experience will be very bad. So these trade-offs are very important in every decision we make. There's an efficiency versus speed trade-off, right? We talked about it. When I batch 2 orders, for example, one of the orders at least, sees larger delivery time. Similarly, there is a speed versus compliance trade-off, right? So especially in prediction models, when we build our models, I'll talk a little bit about why there is natural variance in the data, and no matter what model we build, there is going to be a noticeable amount of error, and we have a choice to train our model in either a way that for most customers we deliver within the promised time, or we have a choice to optimize our models in a way where we are as close to reality as possible, but probably in the extremes it will still break, right? So those choices again are very important. So when we are doing so, now that we know capacity, efficiency has each of these problems, while have their own logistics challenges, they have heavy dependency on the way we use data, whether it's for predictions, whether it is for real-time processing, or whether it is even for debugging and understanding what is happening in the system. So what are the challenges? One is obviously the location capture accuracy. It's a very common problem in logistics, where because of accuracies of the devices, signal presence versus absence, and battery drain considerations and all, location accuracies itself are not very optimal. So one of the problems we work consistently on that is that. Then customer locations and restaurant locations themselves, while we do everything we can to make sure that they are accurate, there are instances where both customer either has not entered the right location, or in case of restaurants also, for some reason or the other, will see that their lat longs are not precisely at the area where they are actually located, and even a slight deviation in these locations could have implications on how we are predicting our models. Then there are, so all of these logistics space, right, it's not just in Swiggy, but one thing that is very important in the logistics space is the accuracy of data, right. Everything else being right, just the nature of capturing a lot of this data from physical human beings is that they are all driven by their own motivations. Right. So, unless we incentivize each of these data input points appropriately, we are bound to get signals that are explicit but not accurate, right. And one of the things that we focus on very highly on is how accurate is our data, because if you don't fix that right now, then our models also learn the wrong learn from wrong inputs, and that's a error that you don't want to be there in the model. So an example of DE behavior is that, yes, obviously he may want to save the battery and so doesn't update the location, but could also be that the DE expects his food to be prioritized by the restaurant if he sends the signal that he has arrived at the restaurant, although physically he may not have arrived, right. So that in his understanding makes his food get prioritized in the restaurant stack, and so his order will get prepared faster, and so he will be very efficient. On the other hand, this is how the human dynamics works, right. Restaurants are smart people themselves, so they know some Ds are doing this, or maybe many Ds are doing this. They also have this thing that they have offline presence, right. There are customers sitting physically on their tables. They are also getting orders from outside of Swiggy, right, whether it is offline or whether it is our online competitors. We don't have access to that data. Restaurants are optimizing for those orders as well, right. So restaurants have an incentive in some cases, especially during peak time, to wait until the delivery boy shows up. Now you see, it's a chicken and egg problem, right. The delivery executive is saying I have already reached when he has actually not reached, and the restaurant is basically waiting for him to come and then say, okay, only then I'll start preparing food, because then it is guaranteed. All of these are things that cause incorrect data input into the system. This is an example. So this is plotted on Kepler.gl, and what we do is we instrument each of the data points, where a certain event happened, what time it happened, and so on. So this is an output of that. You see the white dot here is a restaurant. Obviously this is in some percentage cases of our restaurant, not all, but where it happens really badly. These are the pickup events, where have the delivery boys marked the food as picked up, right. So those are the lat long around there, and the white dot is where our offline method of gathering restaurant location. When you onboard a restaurant, you basically get their name, address, and blah blah, and we also get the lat long there. So this kind of an analysis clearly shows that there are restaurants in our systems which are off from the actual location. So we do this analysis at scale and then figure out what are the restaurants that are greater than X meters away from from the centroid of the picked up locations, and that's how we go and fix proactively the restaurant locations. This is another example which is again done on Kepler, which shows the DE behavior, right. We were always aware that some of our Ds they mark their arrived locations away from the restaurant, but the white dots here are indicating, so the denser regions there are the actual restaurant locations, and the cloud of pings that you see around those denser locations are where many of the Ds have ended up marking the reached location, right? So while we were always aware through you know, plain statistics, you know, saying that hey, X percentage of our D marked locations for arrived, you know, are potentially a geo breached condition. But when you visualize it in this format, it looks very clear. It's very clear that the problem, when the problem happens, it can be pretty bad, you know, because some of these locations could be as far as away as 1 or even 2 kilometers away from the actual restaurant locations. So what do we do about it? We have a lot of product and tech interventions. We have done things like automated detection of location, geofencing, input verification. So if the D is saying I have reached, have you actually reached? Can you look at the restaurant, can you look at the restaurant lat long and the current location and actually judge whether you have reached. Now you have to do this even in the absence of a very strong GPS signal sometimes, right? Which is when you make the decision based on again data analysis. What is the probability that he is telling the truth? You can't block a D because you know that location inaccuracies are there. I could be standing here and my location could be showing off on the other side of the road. It's very much possible, you know, few tens of meters of granularity, sometimes even 100 meters is there. You can't tell a D that, hey, no, you're lying and I will not allow you to mark reach, especially if he has actually reached. So you have to accommodate for those errors, and there's a lot of data processing and error handling that happens to probabilistically judge whether the D has actually reached the location or not. And then obviously we have some operational interventions. These two graphs are you know, our last mile times and O2D, order to deliver time. You can see the variance is what I'm trying to highlight here. The data is pretty much you know, highly variant. It's spread across the x-axis. The numbers on the bottom are hidden. This is not necessarily, you know, a sample from all zones. This is from a sample zone where the variance is very high. But the variance itself is something that is inherently there in the system, right? So the idea is that, as I told earlier, there are so many external factors that are affecting variance, and not each of these external factors are possibly captured by any data science model because you don't have data for it, right? You can develop the best models, even the best model will have some errors, but here there is so much natural variance that even your best model will have errors. So what do you do about it? Obviously this limits our prediction accuracy. And the way out of this is not necessarily, while we do chase accuracies, but you can't not do anything about it, you know. And one of the things that we have tried doing is to proactively account for the inaccuracies, right? So any decision you take, for example, you want to decide when to assign or which D to assign, if your accuracy in prediction is, let's say, 2 minutes, right? And if two Ds are 1.5 minutes apart, then making a choice between them is not going to make a major difference, right? There's one way in which we can use. Although in practice, we actually assume that when such a decision is to be made, we actually assume the best possible you know, choice there. Then identify the sources of high variance. So it could be load on restaurants, it could be the D behavior, it could be the stress on the system currently. And there could be many hyperlocal scenarios like a traffic jam in a certain place and so on. So the goal here is that some data like how many tables of that restaurant are occupied as of now is not something we'll have or will probably ever have. But you know, other things like how many of Swiggy orders are there, you know, what is the menu of each of those items, right? Is it ice creams, is it biryanis, is it rotis, lot of rotis? Each of these food items have different characteristics of preparation, right? So multiple of those you know, inputs are used to increase the prediction accuracies. So next I come to now that we have so many you know, algorithms and so many data focused decisions that we take, how do we actually verify whether what we are doing, let's say you want to do a change in the system, how do we verify whether it's actually functioning or not? So we start with a hypothesis. We go on saying that, hey, if we do algorithm 1 versus algorithm 2, here is what are the metrics that are expected to increase, decrease, move favorably, move unfavorably, and so on. And these are the metrics that are my guardrails, right? I don't want to go bad on NPS. I don't want to go bad on, let's say, my order to deliver time for some cases and so on. So you fix these hypotheses. Then you run the solution, you do the debugging and implementation and everything, and very importantly, do a lot of instrumentation, right? So every single aspect that is possibly could be affected by the changes that you're making needs to be captured. Then we do a very important thing called simulation. Right, so simulation is what is happening in the real world. Can I make this happen in software? Can I simulate delivery executive movements? Can I simulate the order rates? Can I also simulate which areas the orders are coming from? Can I simulate the behavior that delivery executives do? Like for example, at certain rate, I will reject X% of my orders at certain points in time. I'm going to log off at a certain point in a day at so and so rate. Right, so these are different variables that your simulation environment can do. So run this change through the simulation environment, and one of the most important things here we have learned is it's a kind of a challenge to keep your main code and the simulation code in sync. So as much as possible we try and do this together. Then we do a shadow mode execution, right? Because each of these logistics experiments are something that you have human beings who are running, right? They are taking these decisions. So it's very hard to just run simulations and say, okay, what's the result going to be like? Mostly simulation gives directional trends. If I do X, this metric will improve in the range of Z to P%, right? It may not tell us that this will be the precise improvement in the metric when you actually run it on the ground. So you start running it in shadow mode, where shadow mode you're actually getting real life data, but people who are using the systems, they don't see the effect. So you're not influencing anything on the ground, but you're gathering enough data to do analysis both real time as well as offline. And then finally you run on ground experiments, right? So simulation and on ground experiments are something that I'm going to talk a little bit about more. And then finally when the on ground experiments are successful, then we roll out. Now before we get into the next slide, I have a small video. I'll just show a snapshot of it. So this is how our simulation runs. This is a visual representation. All the green markers there are the delivery executives who are free. All the red ones are those where the orders are assigned, and you see those red lines shortening is where the delivery executives are moving towards their destinations. And the blue ones are where the delivery executives are moving towards the restaurants. So this is how we run simulation, and when the simulation on the top left corner, you will see this is a certain zone. There are so many Ds who are free at any given point in time. There are so many the ratio there is representing what is the stress on the system, and the other counts are how many free Ds and busy Ds and all we have. So this kind of a system actually gives us directional results on if I take a certain algorithmic decision, then what is my likely output going to be like. Now once, so this is so this graph actually represents what is our results on simulation versus actuals, right? So you can see the blue and the red line. The red line is the actuals and the blue line is the simulation results. You can see they are not completely on top of each other. They are not like duplicating each other, but the trends are very much the same. Similarly, here is the histogram. The red one is the actual and the blue is the simulation. Again, you see the same observation that to a very good extent we have been able to simulate what is happening on the ground, right? Now the last part is how do you run on ground experiments, and on ground experiments is a huge challenge in logistics because as I said, too many external factors, too many factors that you don't control. So how do you choose a test set versus a control set is a significant problem. Now what we have learned is that first strategy was like simple pre-post. We run without doing any changes for X number of days, then we run it with the changes and then we observe the differences. This strategy typically works well if you have significant impact on parameters and if you have eliminated any large variable changes, like if IPL match happens there's the number of orders like increases drastically. Or if a festival is there, the number of supply, the delivery executive available decreases drastically. So you eliminate some of those large variables, then this kind of gives okay results, but it has to be observable enough. So it has to make a large impact. The other one that we tried was alternate days. This worked a little better than pre-post, because alternate days, the variations is much lesser than it's over a 2-week period. Then the third one is control versus test zone. Can I find a zone which is very similar to the zone in which I'm running experiment? So one zone is control, the other is test. We run it simultaneously for multiple days. In each of these experiments, there is some bias, there is some variance. It's very hard to eliminate each of those, but mostly these are suitable for large variations. Then we have gone into more sophistication. We've tried time slicing. We do a certain strategy for 5 minutes, and the next 5 minutes we change it and so on, or we also do it at higher granularity, 1 hour granularity. And randomized selection of orders, like on certain order we apply one treatment, on certain orders we apply another treatment. Excuse me. And then we measure the bias and variances in each of these strategies. The last strategy which also works in a lot is randomized geospatial selections, right? Can I run a strategy in certain geolocation, whereas in a nearby geolocation within the same zone, you run a different strategy. Now, one of the most important thing here is network effects, where if I take a certain decision for one order, is it going to impact another order or not? An example is that if I change my assignment algorithm, and if I assign one order to a specific DE, it has actually affected another order for another DE, right? That order now cannot be assigned to another DE, which means the behavior for another DE has changed, because that order is never going to be assigned to the other DE. So some of these test and control mechanisms, because of these kind of network effects, you will never be able to apply, right? So in logistics, it's very important to know how do you create the isolations. Right. So for example, if I promise one SLA to one set of customers and another SLA to another set of customers, their behavior can be independent. So in this, you can do the order wise split, right? But if you are doing, if I batch, let's say 2 orders, right? Now, if these 2 orders are batched, they are influencing each other, which means that the second order cannot be batched with the third one in the other set, right? So there are these kind of things that we have to be very careful about. Quick on visualization, when we plot a lot of these points on a library like Kepler.gl, we get a lot of insights that aggregate analysis doesn't give us, right? For example, in this case, you will see that the blue points are where this restaurant at the center, the white dot, is serviceable, whereas the orange and the red points on the externalities, they are not serviceable. You will see some blue dots even on the edge. So that led us to ask this question, okay, why are they there? Why are those red and blue dots very close to each other? In this case, we found that it's because of U-turns and all. In some places, you require a U-turn on a lat long. On the other side of the road, you may not require a U-turn. That makes a difference. There's another example where visual representation gave us a lot of insights. On the extreme right, you will see these are a restaurant chain. Our customers are not doing a great job of choosing which restaurant. Let's say this is a chai point. It's not, but let's say this is. So if I show 3 options to the customers for chai point, which are all nearby and serviceable, the customer doesn't necessarily make the best choice. He doesn't know that the chai point, this one is probably only 500 meters away and the other one is 1.5 kilometers away. The overlaps there are showing that, right? So it's very important in logistics to do these kind of visualizations, without which you will only be restricted to aggregates. Quick summary of learning: know the input data very well, the source of variance and account and accommodate for it. Minimize the input accuracy, fix the data as source, at source, understand the trade-offs, simulations, use simulations and the experimentation very rigorously, right? Without this statistical analysis of each of these experiments, it's not possible to do any kind of progress in logistics. Questions?
Thanks, Piyush. We can take a couple of questions. Anybody has questions? Okay, maybe the post-lunch effect is kicking. All right. So Piyush is around, and if you have questions, you can ask him, and there'll be other discussions happening. So we'll head into a birds of feather session. Can we stop the live stream now? Okay. So I'd like to invite the facilitator.
And if at all.
I'd like to welcome on stage Sudipta Chaudhary from, can we please settle down so that Sudipta can start speaking? Can you please settle down? Okay, I'd like to welcome Sudipta Chaudhary to the Fifth Elephant. Thank you for accepting the invitation to present. I suppose yours is one of the sessions that people have been looking forward to. So let's hope it's an interesting discussion.
Surely. Thanks. Thanks, Anna. Hi, good afternoon, good evening, whatever it is. So I'm at that juncture wherein we are starting the session. But I think there are some more sessions after this. Yeah? Okay, cool. I have, the way I have thought of was that I would put up something which talks about the journey and all those, but understanding the crowd and understanding the people and the expectation that you have, I felt that let me make it more interactive with you guys rather than putting up a boring PPT over there, because you guys are actually writing some 1,000-line codes or 2,000-line or 10,000-line codes. It doesn't make any sense for you to actually see this presentations and all those. But anyway, if there is anything that needs me to hook upon, I will go back to the slide, but otherwise I will rather refrain from referring the slides and all those and make it a more interactive session. It is a small crowd, so it makes sense if you can pose your question in between just by putting your hands up. I don't wait for the last 10 minutes for the questions. So let's make it more interactive. Let's make it wherever you have any questions to understand what we are trying to talk about. Now, just to give you an understanding, I come from an organization whose core business is not analytics. I come from a business whose core interest is not analytics. But then why analytics has been brought in? What was the reason for an organization of nature of telecom to get into analytics? And you guys, wherein you are developing all those interesting products, you are doing some high-end, cutting-edge technology developments. Why is such big things that are happening in the world are not touching big organizations is what needs to be first understood. Now, any organization will be interested when it impacts its bottom line or the top line. Until and unless that touches, then there is no need. Telecom as a business was growing fantastically well. 90s, it had a fantastic run. 2000, the first 4-5 years, it had a very good run. It was all acquisition led. So there was a huge amount of competition and there was a huge amount of market to capture. So there was no need for anything. The gut calls of the managers were good enough for giving that extra fillip and the growth. So there was no need for analytics. Because the growth that used to be seen, if I had not taken any right decision versus if I had taken a very, very right decision, would have been in the positive zone from 12% to 14% and all those quarterly. How does it make a difference? How do I know what is the potential? So automatically people were not interested. When the market started stabilizing, when the market became hyper competitive, when the market showed that there is no more subscribers to go for, Tamil Nadu as a circle was having more than 2 times its population, target population base as well penetrated with the mobile numbers. That means those were the days when there was multiple SIMs, dual SIMs, triple SIMs. There were Chinese handsets with 6 SIM slots. Now, in that market, obviously the market was changing. Then question came, how do I make a differentiator? How do I see that as a... So the organizations and Idea Cellular at that point of time undertook many transformation projects. And analytics was one such transformation project. Just to give you an understanding, we talk of data, we talk of today's petabytes and of data and all those. But in that time, I'm talking of 2008-9, when I joined Idea and took up this charge of analytics. At that point of time, even the definitions that were used for defining a customer was not in place. Who's a customer? How do I define a customer? Is not, I'm saying that not that from the perspective of the mobile number is there perfectly fine. Is it a revenue earning subscriber? Is it, what type of subscriber is he? Is it a zero usage subscriber? Those definitions are needed to be put in place. So the warehousing, the data, all were put in place and then started the journey of analytics. So I can say the triggers always of such absorption of analytics comes when there is a business need. And that business need in those days were competition, hyper competition I would rather say, 9 to 10 operators in each circle. So where is the pie to chew from? So that's where the market started changing. Now where was the focus then? The focus came to be churn management. There is a huge number of subscribers who are churning out. They are moving from my operator to my other operator, then put something so that I can hold them back. Now herein, when I say this, I also need to highlight one thing. I need to tell you guys that whenever as an analytics journey, you embark on this journey, and I'm sure you are now in developing something, you are productionizing something, you are leading some organizations, perfectly fine. It is important for you to estimate the impact of your work in the overall scheme of things, and it is very important for you to understand and estimate it and tell the organization that this is the impact that you are expected to have if you go ahead and do this. How do you prioritize your impact areas? So that's one thing that is very, very critical and crucial. So just to give you a feel of it, anyway, by the time it comes up, just to give you a feel, there are hundreds of different use cases and there are hundreds of different operators and partners who come up to us on a regular basis stating that we have done this in so and so country and we have done this in so and so operator, then why can't we do it in your organization? How do we choose the right thing? How do you make the right pitch? How do you understand the business problem before you make the right pitch? How do you take up these and prioritize those are the areas wherein it is to be understood. Now anyway, so we embarked on this journey, we identified projects, we identified areas. Now the question is, when you start this, problems are identified, just to give you, this gives you some understanding. In the telecom world, what are the different areas wherein analytics can be impacting? So obviously, whenever I'm going and talking to my senior management, if I go and speak something, might not be internally valued. But when I go and talk that the Gartner is saying so, then it gets valued. It might be so that I'm coming from Gartner and doing this pitching here. But anyway, so it impacts. So the brand value is very, very important when you work in a big organization. Who is speaking? Who is coming and pitching on that? So that is very important. So you have to get some right names behind you to put the point across that you want to drive, right? So herein we identified the broad areas wherein we could make an impact upon. Now question came, is that fine, this is important, so start doing it. So what's the big deal? Start doing it. So you have a problem, you have data already coming in, so start giving us models. What I found in this journey, I'm not getting into this journey at all, is that it is very important for us to understand how we set up this whole ecosystem. And that's where you need to be understanding what are the questions, what are the strategic decisions that you need to take so that you can build it in a manner that is sustainable. And when I use the word sustainable, as I had personally was involved from 2009 onwards until date setting up the whole thing, let me be very frank with you guys, I have seen that people come and join to enrich their CVs. So it is important for the organization to understand and take a holistic understanding and take a long-term view rather than encouraging something that is not sustainable. So it is very, very important that you need to understand whenever you are pitching something, whether you are doing it for here and now or whether you are doing something to impact in the long run of the organization. So that makes a lot of difference. So if you have to make this whole thing sustainable, then you need to take decisions which are futuristic. So with this statement, let me just go back one slide. If you see this, the evaluation phase of anything that we are doing was pretty long, and you might be in today's generation, you might not be interested in having situations which is such long evaluation period? Because you will be saying, if I spend 1 year on evaluation, I could have delivered something really fast. But please understand, it is very difficult in big organizations to change your path midway through. If you have taken a decision, you have to make it a successful one. Though today we talk about learn, fail, again recoup, and again run, you can't change direction so very easily in big organizations. In big organizations, you have to prove your mettle, you have to deliver it, and then only you can go on. Otherwise, you lose your face, you leave the job and move on. So you have to be very sure of what you're proposing. The evaluations that we went about doing were with big names in those days. I mean to say, and today we are talking of R, Python and all those. In those days, SAS, IBM had brought in SPSS and all those. We had a thorough evaluation and finally went with SAS as a platform. In case of the IRIS, which I talk about is a CVM, that is a campaign management ecosystem, analytical ecosystem. We had brought in McKinsey to be the partner, to be laying out the whole thing, how the whole campaign management ecosystem will look like. When we went about the BI, it was IBM as our technical partner, brought in DB2 as the warehouse. So I mean to say, it is all long run, effective decisions that needs to be taken. You can't take short-term vision and you can't make those calls which will be not paying you in the days to come. So as I was coming back and talking about the question that we asked ourselves, just to see for yourself, if I was looking for something to be delivered fast, pitching the next day to my competitor and getting that particular account. So again, a big organization will be very cautious about taking that steady step wherein they are sure that what I am doing is going to stay to some extent with me and it is not replicable, it is not copyable. So that's something that is a very quick, agile organization versus the big organizations slightly differ. So that is the first question that we had answered. So to keep the IP within, we had got it whole developed in-house. Another thing that analytics setting up requires, most interestingly, the cases comes from the marketing. Okay, so because let's do something with the marketing function, and in a telecom company, sales another area, service delivery another area, finance, the revenue assurance department another area, network another area. So why can't I have multiple analytical instances in each of these functions? We can have that. And it is very easy for everybody to have their own fiefdom sort of thing. I'm calling it fiefdom. So that my analytics resource does analytics for me. And what analytics? And in the name of analytics is MIS publication. So to avoid that, it is important that the organization takes a call and values the true sense analytics and sets up an analytics wing or a division or a department which is going to serve across a different function so that it is able to gather the knowledge, it is able to understand the problems, it is able to crisscross the learnings and make it a more enterprise-wide and analytical venture. So that's where the question came, whether we had spread instances in each and every circle. For us, we have 22 circles across each and every operations and geography, and we have these different functions. So that's the call that we need to be taking. Again, when it comes to the campaign management, a very easy way out is that out-of-the-box solutions. You pick up something, you just fit it, plug it, and then start rolling out. And many of the organizations today also comes and says that we can be giving you a solution to you in no time. So you just plug in and you can start working. The problem, if you go with that, they have brought a product which has worked in Europe, which has worked in US, did not necessarily mean that it will be working in Indian prepaid telecom scenario. So it is applicable not only to telecom, it is applicable to any product that you develop in your own domain. If the product that you are trying to say it is out of the box is not relevant for the market or the product or the company or the culture of the organization for which you are working, it is not going to be accepted very easily. You will be getting into a situation wherein every now and then you will be asked to change. And how to avoid that change, it is important that you understand the geographical tenets, you understand the cultural tenets of the organization before you propose a product for it to be taken forward. Otherwise, it will be taken. I'm just giving you a simple example. If your organization is an Indian organization wherein the numbers that you are putting out is reported in million, he'll be coming the next day and saying, crore mein kar do yaar. I'm saying it can be going to that micro level. But if you show him the product in a very first day crow, you might be finding, he is relating. So those are the small things that needs to be taken care whenever you're taking something out of the box and customizing it. In our case, we got it customized. In our case, the whole solution was customized to the level that we will be looking for a platform. You give us the capacity and the capability. We will say how it is. So we became the product managers. And the partners became actually the engineers who delivered it, and they delivered really good. A very important aspect of the starting in the analytics journey is that measuring of the returns. It's very, very important, because how do I justify the next year when I ask for an extra budget that I want this much? And the next question, what did you do? What was that effect? So it is important for us to justify the effect. There are two ways we do it. One is obviously through the monetary terms. If you can justify it through monetary terms, well and good. But if you are doing something which is not so tangible, because many times if you are making an analytical proposition, the campaigns that are being run on the basis of that, or some strategic decisions that have been taken on that, and the impact that has been seen might not be happening the next month. It might be happening over a period of time. It might be difficult for you to quantify. So how do you make your work valued? Find ambassadors within the organization who can be talking about your work to the right people at the right point of time, so that you get the right budgetary allocation the next time. So that was one route that we had taken, because it was very difficult for us to prove the value that we are giving in tangible terms on day-to-day basis, because whenever I say a campaign is run based on analytical models, models say this is the guy who is going to churn and this guy did not churn after giving a product. Who claims that the revenue out of them? Is it me or the analytics guy? Or is it the product guy who has developed the product? I mean to say the construct of the product in this particular case, not the product that you develop, but the 26 rupees recharge gives 35 rupees talk time. Is he going to take the benefit of this? Or is it the guy who has communicated because he wrote a script and all those? So there is always a clash between these different teams who will be deciding, saying that this revenue is mine. So to avoid that, and you decide who is the owner of this whole program, and if possible, try to see what is your share of that particular thing. And if you're not able to do that, please find good advocates, right advocates for the work to ensure that it is being taken through. So that's very, very critical for the journey to begin and the journey to give a concrete size and shape. And obviously driving adoption means you have to make a cultural change in the organization. People will be saying that I know this better than you guys. You guys are, you know something in the statistics or modeling and all those things. You do not know the dhanda. That's the normal terminology that we get to hear. Dhanda humko malum hai. So you don't come and try to preach me. But how do you drive the adoption? So you generally say, okay, fine, I completely agree to you. Let's do a testing. Let's on one base, you run the campaign. On small base, give it to us, or half the base, you give us a base. Let us run the product. Let's see how it performs. And when the results come out, it becomes much more easy for you to convincingly convince the person and onboard him on the journey that we are talked about. That's the route that we took to ensure that analytics gets driven. And analytics got driven in our organization, not from the top. We always keep on hearing that analytics needs to be driven from the top. And I personally have found it to be better working as it went from the bottom. So there was a need for analytics coming from the different corners of the organization. There were people who were asking for those things, and obviously it was supported by the top. That is the reason we are here, and we have enlarged our team from 2-member team to a 40-member team. But the actual ask came from the bottom. So that made it really grow, and they became the guys who were using it. So those guys who were actually doing product, they started doing analysis. They were not doing analytics, they were simply doing analysis. But in the name of analytics, they were also putting the point that they're also doing analytics, but whatever it is, so they're also doing it. So that's the way it went about changing the way. Now question is, what do I do in the name of analytics? What is that we do? So what is your field in a telecom scenario? What are the things that we can be doing? obviously someone or other must have worked in a consumer facing industry. What are the areas wherein you feel we have been doing our work, and what is the nature of analysis that we do? How we can excite the people, the business managers, with something which they did not think of? Obviously churn, cross-sell, upsell will be the areas wherein they will be asking for and you have to deliver. But how the excitement is created, because analytics is something that is something to excite. If you can't excite it, you just can't give models and say, I give you revenue, they are not going to be listening too much. So to excite them with something really funky, along with your regular mundane work, because otherwise they are not going to sit through your presentation for 45 minutes or 1 hour listening to all those things that he feels that he knows. So it is important for you to excite the things that he doesn't know, which you know better. So it is important in that manner. So can you give me some examples wherein he doesn't know and we as an analytics fraternity can be guiding him in a better manner? Like? Very, very nice example. Just taking the word and then using the word. Campaigns when are being made, mostly the campaigns today is being not made on SMS is not a very effective medium. But 5 years back, 3 years back, SMS was the most effective way of communicating. Fine. So if I am sending an SMS in a language which the person can't read or can't relate, obviously doesn't make any sense. So it is important for me to communicate with him in the right language. And when I say the right language, I need to know where is he coming from, what is his language preference. Hardly a bare minimum, around 5 to 10% of the guys actually puts their language preference in the IVR. But what about the rest? So if he is in Maharashtra, send everybody Marathi? Absolutely no. Nasik has got a huge population who is migrant coming from the UP East and Bihar. How do I find it? I find their traveling pattern, I find their calling pattern, I find their usage pattern, I find their Lokmat and other news channel subscription pattern, and thereby I am able to understand this guy might not be a true Marathi speaking guy, but some other language guy. And that helps me to identify it and then push a SMS if his handset supports it, and then makes a difference. So you can understand in this way how the analytics makes a difference in each and every aspect of that. Again, communication, another angle let me talk about. Communication has got different time points, has got different response rate. Some of the guys respond more if you send the SMS in the evening. Some of them respond more if it is being sent in the morning. So again, if you are able to prioritize those time slots, it makes more effective way of communication. So if these things are something that you find out, insights generated, talk to the business, then you go and propose your thinking, then it makes much more connect. Then the people start, okay, fine, he is talking sense, he is understanding what my problem is, he is helping me in increasing my take rate. So thereby the connect comes up. And obviously you have to do this with, not with those the codes or the jargons and all those. You have to go down and say, if I had sent this SMS on so and so time, this is the take rate. If I go with this model, this is the amount of take rate increase. That they connect and they are able to relate. So that's somewhere you need to understand and appreciate and give them that particular comfort zone for you to take forward your work that you have done. So that was the way we went about creating excitement around small pieces such that it can be taken forward. Just to give you a feel of it, I'm coming to this. So this is the nature of information that a telecom guy will be having, usage based. Any day they will be having all this information. How much time you spoke, whom do you speak to, where from you spoke to, which handset you are using. All these are transactional data, right? So how do you make it more interesting is that when you go beyond this and try to say, I'm not only giving you this, I'm also trying to give you age. Age is not available to us, can you believe it? In today's world, we don't have the subscribers age very confidently. Why? Because when we go and fill up the form, many times we do not give the right documents. The retailer gives his own document as mere padosan mein hai, le lo. So where do I get the age from? How do I get the gender form? So that's where you try doing understanding the subscriber in a better manner, understanding the subscriber from the different footprint that he leaves. That means whether he is ordering on Amazon, whether he is going and taking the product from Amazon, or whether he is browsing Netflix for more hours, How do I understand all this and then try to understand his age, his gender, and all the other aspects, and create a persona of that person. So that's the nature of activity that goes behind to excite the people. And it is not only this footprint that he leaves, but also the digital profile that we can create of the subscriber to get a better understanding of the person. And then we can pitch the subscriber in a better manner, in an effective manner. I'm just taking some marketing use case for you to understand what is the nature of analysis. I'm not getting the other aspects of network, sales, customer service and all those. I'm just giving you a few to understand it. Now that's the way the whole thing got developed. But what is important for you guys to appreciate and understand, and what I believe, let me be a bit more giving some sermons over here, it might be sounding that way. I feel the 5 pillars of any organization's success is these 5 to begin with. You need to have this, otherwise this doesn't go through. So you need to have the right technology. As I explained in the first part of my session with you guys, is that when I say that technology needs to be forward looking. It can't be here and now. In big organizations, you can't be doing something for today's thing. It has to be for the future. People, that's another very, very critical thing. I had seen all. I had seen enthusiastically people joining us. I had seen enthusiastically people leaving us. And I had seen again people joining us. And of late, I am seeing again people leaving us. So I have seen the full cycle 2 times. So why people leave, and how can you make people stay back? You are in an age wherein people switch for any damn reason. Believe me, people are leaving because of any damn reason. Gone are the days when people walked in one organization for generations. It's over. So people will be leaving, and especially this community leaves at a much faster pace because the market is hot. It's not because they have always chip in their shoulder, because the market is hot. There is always a demand for these resources, so they are able to leave. This same guy would have stuck to the job for a longer duration if there was no demand. Let me be very candid on this. So they don't wait for the hike, because if I go change, I get 20%, 30% hike whenever I change. So they don't wait for the annual increment. So they change. So how do you hold them back? How do you ensure that they are with you? The important thing that I have understood and I have tried to inculcate was the modelers who are being hired, many of them freshers from premier institutes, also not so premium institutes, were given tasks where they were not differentiated. So there were guys who were made to do the end-to-end of the modeling job. What I mean by end-to-end job is that organizations take a call wherein they make some guys, the junior guys, do data cleansing job. Then slightly senior guys doing the modeling job. And slightly more senior guys will be doing the talk job. That means they will be going and getting the projects and all those. What I felt with some initial interactions was that they are actually looking for a holistic experience. They don't want to do the cleaning job for the first 2 years of their career and then move on to the modeling and then move on to the development piece. They want to do it from day one. And believe me, those guys are nowhere different from the guy with the 4 years of experience. Don't give a very complex problem to them. You can give a comparatively simple problem to them, but make them do the end-to-end job. That means he pulls the data himself. He ensures that he develops a model and make him the owner of that model. And that way I have seen that they all stick to the job. And that way I have seen or ensured they leave the job because they are ready for the market. So it is a catch-22. You decide how much you want to make those guys stay. But somewhere in the long run of your career, I look back and feel it was a good decision because in some way those guys' career, those guys' ability to develop as a resource and thereby the fraternity in which we work has developed. So that way I see good, but obviously when I see, अरे इसको तो मैं तैयार किया 2 साल इसके पीछे मैंने, but he's left, and one fine day he just comes and says I am leaving. So very, very difficult situation. People is a very, very critical thing in this whole journey, and I'm sure everybody is facing or everybody is doing either of the two. So please be very careful as that 10%, 15% hike and moving because of that is not the right decision that I can be very sure of anybody to be doing. see for the profile or the growth opportunity, the learning opportunity before you make any decision of that sort. So that is very, very important for any decision. Even if the team is doing that, please ensure that they don't do that. Data obviously was not a big problem for us because we had all possible format of data that we wanted, so it was not a thing. Now the last two is very, very critical for our journey, and herein I can say that it was very, very important. Reason being, if our work is not deployed, if our work is not streamlined and flowing without any hindrance to the campaign management ecosystem or the sales app, then the whole work that we have done is meaningless. So, as I have made the person, the junior most guy, responsible for the work that he does in terms of data collection, data preparation, data modeling, data out of time testing, out of sample testing, and going and selling to the market, he has to be responsible for ensuring that the model is deployed. He has to be made responsible for ensuring that the value that he gets out of the model being seen and then come and talked about. So his annual appraisal that is being done, you don't come and say that I have cracked such and such code. Very good, you have cracked, well and good. I have cracked that business problem, fine, fantastic. But I will appreciate only when the thing that you have cracked is being deployed, only when the deployed status is a regular run status, only when the business has adopted it. If business has not adopted it, that means you have created something for your own fun and your own liking. I don't value it. So it is important for giving that message to the people in your team that you don't create to enrich your CV. You create something for being valued by the organization, and that's what we are all working for. So once that message goes loud and clear, I found comparatively the nature of models that got developed, the nature of problems that got developed was much more adapted by the businesses rather than something else. So obviously for their intellectual challenge there was something or the other given, but that was always linked to the business problem or the bigger problem that we are trying to solve. So that's the way we could take care of the people problem that we are talking about. And adoption is obviously very important, and that's the way we ensured the adoption happens from the business side, and that's the way we ensured that adoption happens from the people who are developing it. You don't get it adopted, I don't value you or the work. So that was the bit. This is something that went about developing models. This is not important for here. This is how we develop. Okay, this is an important aspect that I need to talk about. If the rightmost bottom corner, models developed with around 10 variables. Why this concept of 10 variables? This is something very important that I felt is important for me to convince my IT counterpart that if I give a solution which has got 30-40 variables, my modeler is very happy. Because he says that I have done this, that transformation, this transformation, and I have been able to give that extra lift in the model. Fantastic, very good. But they, being young, energetic, enthusiastic team members, they do not appreciate the fact that getting a model with 30-40 variables when the model is so very complex, it becomes very difficult to deploy. And becomes much more difficult to make it run on a daily basis. So the one line message to them was that you develop something, it needs to be deployed. It shouldn't be so happening that IT comes back and says that no, we can't deploy it. So the models, and I found very categorically, those extra 15-20 variables that come and use, if I remove all those and keep the model to a basic 10, 12, 15 variables, doesn't make a lot of performance difference. And even if the performance difference is analytical, it doesn't make a lot of difference in the overall revenue terms. So if the model that you have developed might be very complex, very interesting, very cutting edge, but is not able to give a performance lift in terms of your model performance, and furthermore it is not able to be translated into a revenue performance, then we don't value. So what I'm trying to tell you is that as an analytics fraternity, we get excited by using a lot of interesting data. We get excited by something that I have read in some journal of Norway and getting implemented in my own organization. But if it is not delivering the value that it is supposed to deliver, it's very difficult for people like us to accept it. And please bear with it. So that's where the complexion of the game slightly changes. And I know when I am on this side of the table, I will be saying that I would like to do those fantastic job, but it's tough for me to say no to those suggestions that these young, bright, enthusiastic, energetic people like you all, sparks in their eyes, come and suggest. I can't take it always. Reason being, at the end I have to see that the environment runs. And many times I know that they give gali behind my back. So, this is where I was talking about the deployment. Deployment is very, very critical and has to be. And so whole process has been streamlined. The model building has been streamlined. That means the model building that I talk about, this wherein we are converting the variables, around 100 odd variables get converted into 700 odd variables. That process is streamlined. So the codes are defined, is in the system. So it is all that way taken into picture and then ensure that it is, you can't change very often now. You have to change something, come and make a proposal. In a quarterly update of the model of the whole environment, we'll be incorporating your suggestion. So basic, I'm just giving you an example of the overall, how the CLM, this is a very, very basic rudimentary slide. The overall CLM, that is a customer lifecycle management that happens, the whole thing works through analytics, but there are different stages wherein the analytics touches it. And obviously the important thing that we always go down to say is that how is that going to be measured? How is that you are able to make an impact into the whole thing? So that's how the whole piece, in a very simple way, I have put it over here. It is not so simple. Obviously, when we talk about today, today the unlimited has taken a lot of charm out of telecom products. But otherwise, when we were running campaigns in the mid 2017-18 types, there were around 4,000 campaigns being run on a monthly basis. And 4,000 campaigns being run on a monthly basis is not a very easy thing, and the campaign management ecosystem had to be geared up to run those. So obviously all our analytical modules had to make their scores flow into the system, had to make ensure that the communication is in place and things go accordingly. So I can leave this talk and leave it the last 5 minutes for you guys to ask any questions, because I thought it will be interactive, but I rather zoomed past. So these are the different things that I feel was important for our journey and make it a more successful one. So I touched upon most of them, and this is for you to read, but mostly these are the areas wherein we went about and made it a successful thing. So that's the way we went about in Idea Cellular. Today, as in the last 3 months, we are more working towards ensuring that the Vodafone Idea 2 databases coming together, and we are more working towards how do we make it a big analytical platform for both the organizations and all those. But more importantly for us, for me, as I had said, the whole analytical journey for Idea Cellular Limited, and in the telecom domain, it was pretty robust and going good. So this is where we went about, and this is how we went about. In a very short 30 minutes, I could capture this much. I leave it open for you guys to ask if there is any question, so that I can take it up and take it forward.
Yeah, the elephant in the room, Geo.
Come again?
The elephant in the room, Geo.
Yeah.
So what is
it has already made the Geo, let me put it in a lighter way, is that it has already ensured many telecom companies are no longer Geoing. So, and many big telecom companies had to be forced to merge, and we are also one of them. So it is an impact, but it is more from the telecom perspective. But the way the telecom has changed, I mean to say the per minute billing, going to per second billing, going to and now making it voice free, making the unlimited coming into picture, is obviously a big change in the telecom market. So the learning for analytics over here is that we might be creating a lot of assets, analytical assets, and take pride in it. But one market disruption creates a flux and thereby washes off all the different analytical assets that you have created. And Geo has ensured that all the analytical assets that we had created over the last so many years had got flushed out, and we are now running very fast to ensure that we create our new assets fast. So that's one impact on analytics that I can comment on. Yeah.
So I actually have 2 questions. So the first one is, so considering the Vodafone Idea merger, so how the new analytics, your entire architecture shapes up. So I'm assuming Idea had something else, Vodafone had something else, right? So they might be following some different. So how the new architecture shapes? So can you share some light?
Okay, the thing is, at this point in time, it has got a huge implication. The cost has got a huge implication on the decision of the architecture. we would not like to go in day one itself, and that is the way we did not go ahead and try to create a new architecture, a new warehouse, and ensure that the data starts pumping in. So that is the first thing we said, no, we are not going to do it. As I said, my first thing is that it has to be a robust and long run thing. So the way we are now going ahead, all the reporting requirements of the organization are being individually done by the two data warehouses, and is being taken forward. So at a definition level, you can take care of both the things, and then you can bring it in one platform and then can start reporting over there. But when it comes to the analytical problems is initially being taken care of by when you have independent models running on the two data warehouses. But going forward, the way it is going to be, it is going to be wherein the data from the different source systems, I mean to say network and IT source systems, is going to come to the big data ecosystem. And the big data
You might have to bring them to the same schema, same architecture. Not today, not tomorrow, maybe in
it has to eventually happen. Right. But when we are hard pressed on network investments, so these backseat.
So it's like architecture, ETL. And can you give one example, like how customizable impacted your business decision or
followed? So our whole of the campaign management ecosystem, wherein I'm running 4,000 campaigns, there were Unicas of the world which was pretty well established. And they were running those campaigns in the international, globally, and they were really nice. No complaint against the solution. But what was problem was that our segment managers wanted to do something differently. They wanted dynamic campaigns. That means I create a static campaign and then I get triggers in between. One subscriber has to be moved out of this and made a dynamic campaign. Now this is a very simple thing in your and my mind, but many of the platforms do not have the capacity to do it. Even if they are able to do it, then they are able to not tag the revenue earning from that subscriber from that day when the movement happened to this campaign. It will be going to the previous. Those small nitty-gritties ensured that we moved to a customizable solution. And the big differential that the quarter on quarter the growth that IDEA had made, this IRIS, the campaign management ecosystem that we had put up. IRIS, by the way, full form is increasing the revenue through intelligence of segmentation. So it is, so the whole thing worked really well for that, those quarters when this customized solution was in full blow going and hopping. Yeah.
So my questions are around, or the question is around what I heard earlier, was that you were talking about models being robust and change, if a change had to be allowed, you have to come in with a proposal, we'll take it up in the quarterly review and deploy it. And now that there is an elephant in the room and you say you have to move quickly, so how does that change? So does that have an impact on how your engineering works, or does that have an impact on how your data science and analytics team?
Now, to answer that question is a nice question. The thing is, though we are saying we have these type of models which is going to be developed and quarterly point of time, I'm saying that quarterly review will be taking care of all the proposals and then making the process change in terms of making the necessary lift. On a continuous basis, there is a challenger, the champion challenger approach that is always in vogue. So if there is anything that is happening, that will be taken care. But the recent changes that are happening in the market, you have self-learning models deployed, which is trying to take into consideration the change that is happening in the market, and then you accordingly take it up and then run the things. So currently we are moving more towards that type of environment rather than going into the traditional environment. But more importantly, which is to be appreciated, the focus of the telecom analytics from customer churn management has substantially shifted. Nowadays we do no longer get into that type of work. We moved out of that over the last 1 year, and that is all because of the market change that has happened. It is more into optimization game. Today the whole area of analytics is happening in the mode of area of optimization. If I have this much resource, how do I give targets to the retailer? If I have this much resource, where do I put my network? So all those analytics that has changed is because of the market change that has happened. So rather than changing the model's approach, it is the model's objective being changed. Right? Fine. Anything else? Fine.
Is there any other question?
That's fine. Cool.
Okay. Sudhir, thank you so much for this powerhouse presentation at 4 p.m. in the evening. Yeah. Thanks a lot for accepting our invitation and for coming over.
Thank you.
Okay. Next up, we have Kaushik Bhatt, who will be making a set of remarks on the challenges of data governance from his perspective.
Thanks, Anab. I'm standing in before your time to leave. I know this is the, when Zainab and I were talking about this topic, data governance was the topic we wanted to pick up. And I know this is group of data scientists, data engineers, and talking about data governance here is probably a dry subject here. So first of all, I'm not going to put any slides. I don't want to bore you with the presentation. By the way, by introduction, my name is Kaushik Bhatt. I work for Wells Fargo. I am responsible for data management and governance. And the reason I say governance because it's an area as a bank we have started to focus on. And those of you who don't know Wells Fargo, it's US fourth largest bank in terms of revenue. And in world, we are among top 10 banks as the revenue, assets are concerned. So let me just quickly talk through you in terms of what is governance, what we do and where it started and how we see this is going to impact the spectrum in India as well. And that's where I'm going to drive the topic here. So we've been doing data management for last 20 years. As a bank, we have a data warehouse. You can name a technology, we have it. Right from structured data, unstructured data, data lake environments. We have done everything, by the way. When it came to 2016, as a bank, we were asked, can you give us some numbers from regulators, by the way? This is where it started. And I cannot talk in details, but essentially, when it came to our analyst community, to get a one single truth was difficult. And we went to a data scientist, even today, if you go to data scientist community and ask a question, can you get me a good data? A lot of time we see the data scientists are spending time in finding good data. We saw that the struggle of success of data platform is to do with right data and data in a way where we can be consumed faster. So our effort was really to make sure that our data assets that we have are 100% consumed effectively. So this is where the program got started. I'm part of CDO office, Chief Data Office. Our job is to really look into data lifecycle, right from data origination to data processing and consumption. So right from knowing your data, let me give you an example. All of you, and in the entire day I heard people talking about all types of data being ingested, right from your location data, telcos we're talking about, monetizing for social engineering, and all sort of data is getting into a system. First is, do you know what you're getting into it? Now, as a company, especially product companies like yours, you have a clear use cases which you are bringing in. But a lot of time, data scientists will bring data for monetization, which multiple use cases, and they don't really know whether they need it or not. So in our case, or most banks, we would end up creating data lakes into data swamps. So we had a lot of data which we didn't even knew why we have it here. If you look at, that's the first problem. Our effort 2016 onwards, we've been going back to our data. We have deployed, I would say, data scan mechanism. So we know whenever we get data, we know what data it is. It is sensitive, if it is PII, or if it is confidential, we know it right there. Our endeavor is to really make sure that every policy of the bank or any financial institute is being recorded in the part of scan itself. Let me give you an example. If you know your data, a lot of times you would want to make sure that your phone number and PAN card, in Indian context, phone number and PAN card shouldn't be compromised. Let's say if you're a fintech, you are dealing with Aadhaar-based encryption, Aadhaar-based validation, your PAN card details, date of birth, location. By the way, this is super sensitive data, and if it is being gone into wrong hands, potentially you're going to lose the customer trust, and we all know what happened to Facebook and what's happening in terms of different companies. So as a bank, what we decided is we want to make sure that we are responsible not only for our data scientist community, but we wanted to go out and tell our customers we are responsible in terms of how we handle our data. Three things. We deployed our data lake architecture with profiling systems. We also deployed scalable data classifications. So if I get a data which talks to me as 16-digit number, I know it's a credit card number. If I get a data which is starting with 4-digit number, which is Amex, I know it's Amex card. If I know date of birth, I would know that this is date of birth an address or a person where it resides. So right from ingestion, we deployed our data classification and tagging. We also made sure that if you know Amazon, the way it does cataloging, and in fact, I'm sure in your data platform you have deployed it, we made sure that every data asset is properly cataloged. So we deployed our AI ML algorithm there, we are deployed on products, and we make sure that every data asset that we're getting in our system, it's getting cataloged properly. And we make sure that every data asset being transformed from ingestion to consumption, we have MDM system lineage. So that's the other thing that we have invested on. Last but not least, data protection. So whenever you find a date, whenever we find a SSN number in our US perspective or address number, we make sure data is masked. And there are a couple of things that we do. We do tokenization, we do encryption, we also do, in some cases, we do masking. Again, these are different techniques of protection. Each technique has its own merits and costs associated with it. We ensure that if at all you have access to data, the role demands it. We make sure that business is owning these policies. We make sure that there's a steward who's assigned to the policy and whoever gets access to it for the purpose, and the purpose is defined, and it's part of our policy. Again, this whole life cycle is looking like a barrier to data scientist community, if you ask me, whether it is going to slow us down. But our experience has not to really slow it down. Our experience has to really make it better. Because if you address the quality of data, if you address the data itself is properly cataloged, your search mechanism for data scientists become easier. We saw benefit of doing this because we were able to get our data assets much easier. We were able to find where to get the right data for our analytical projects. Also, we were able to make sure that we are responsible in the way we handle it. So that's what we have done. I really cannot go specifics of products, but I know we have some. If you have questions, we can take the questions, or we can talk through the specifics. We are in Bangalore, Chennai, Hyderabad.
So there are a couple of questions. First thing is like, what about the data retention, right? So you said like you have a discovery mechanism to identify the data sets. So, but what about hot versus cold data, the storage trade-offs there, right? And what's the SLA to make the cold data hot into hot?
Yes.
That's one question. And yeah, I'll ask my next question.
So again, data retention policies are defined for the bank per se in terms of what we want to keep in our hot data. Look, there are policies around operational data, policies around what we keep in data lake, and based on our use case, we make sure that data is either in hot, available to our end consumers, or it is kept in tape backups for retrieval. So if your question is how do you really ensure it, we make sure that our transactional data is kept in our data lake environment. We have our referential data and foundational data in data warehouse. We keep 3-year history at any point in time as far as our data warehouse is concerned. And transactional data is depend on the use case. I would not be having specifics, but we do have up to a year data, or even some cases we keep a month's data for use case.
Second question is, with the cost of ingestion, right? So you have transactional databases and data stores, and you have data lakes. But what is the cost of ingestion? Because you are already ingesting into your traditional warehouses.
Yeah. And
then again you need to ingest again.
No.
Yeah.
So we have actually, when we invested data lake, our first strategy was to really design data lake with the concept of raw data store. So a lot of our data feeds that were traditionally going to data warehouse are now getting fed to raw zone of data lake. So